Guys, and welcome to another day of doing NeetCode. Today we're doing search a 2D matrix. So basically, we're given a matrix or a bunch of lists. And we gotta find out if a target exists within the matrix or not, and we have to try and do it in the best way possible. Logic going into this, what I'm gonna try and do is I'm gonna try and check the first integer of every row is greater than the last integer of the previous row. That's what we know. So what the first thing I'm gonna do is I'm gonna check. I'm gonna be like, okay, I'm gonna go through every row, and if only if the last integer is less than it, then I'll go like descending order. Cause like I'll check 8 and 8 is less, so I'll skip it right away, and then I'll go 13 and I'll just check the entire list from start to end. So I think this should work. So what we're gonna do is we're gonna get, I need a we have target. I think I just started 4, so I do 4 rows in matrix. Okay, if rows at -1 is bigger than if I wanted to do something is bigger than target. Yeah, is bigger than target, is bigger or equals to target. I guess I could hit a return true right now, but I don't think it matters. But if it's rows at -1 is bigger or equal than target, if not, it's just gonna go to the next row. Then we'll say for num in row, if num equals target, return true, and then over here we'll just return false. This is about to be the quickest 2-minute. Rows. Wow. No way we. Oh. Try again in a moment. Wow. Okay. So that one took us, no joke, 3 minutes. Like, we just started this right now too. Solution is going crazy right now. Whoa. I'll be honest. They doing too much. So we're just gonna continue up. I can't lie. We did this one. I guess we're gonna skip right to Koko eating bananas. Just because, you know, that took us 2 minutes. We might as well hop on another one. But this one, haven't tried it. We're given an integer piles, where piles the number of bananas in the ith pile. You're also given an integer h represents the number of hours you have to eat all the bananas. You may decide your bananas per hour eating rate k each hour. You may choose a pile of bananas and eat k from that pile. If the pile is less than k bananas, you may finish the pile but cannot eat from another pile in the same hour. Return the minimum integer k such that you can eat all the bananas within h hours. Okay, so yeah, with the rate of 2, you finish this one in 1 hour, then you finish this one in 2 hours, so you have 3 hours, and this one in 2 hours, so you have 5 hours, and this one 6 hours. Oh. So this doesn't seem very fun. Okay, I think what we do is we hit the binary search, but we do it with K, right? So we'll say top or bot K equals 1. Top K equals max at piles, right? Whatever the max is. And then we need a function. So see, with this or with this. Oh, we need a mid. Oh, wait a minute. Ooh. Like I don't want to start with 1, but we're looking for a minimum integer. So I do 4 while bod K is less than top K. We need to get all the we need to find a way to like we'll counter and then we'll say okay, so while and then we should create like I equals while piles at I just create a new one. I'll just create like copy equals piles copy at I is less than or equals. I minus the middle, I think we're gonna do, so we'll go I think we'll find like this. If counter, nah, okay. Like I'm kind of stumped. I don't know. Like, I'm just writing stuff to write stuff, but I don't really, I need to like understand stuff. Max equals piles, while bottom is less than top, mid equals that, counter equals 0, copy equals that, counter plus equals 1. At the end of this, we have the amount. So if counter is less than h, top bot k plus equals 1, else elif top k plus equals no, return. I have no idea if this is gonna work. This is gonna give me like a time error. Okay. Damn, the other one was so easy. I'm sorry. So okay, we're gonna restart. I don't want to like delete this, but like I'm gonna delete this. I don't want this. Okay. We want to find the minimum integer k, so you can eat all the bananas within h hours. Okay. So we need to start. Yeah, we have k low equals 1, and so let's put it back. So let's just delete this. So k low equals 1, k high equals the line of pile equals the max of piles. Okay. Whatever the max number is, that's what it is. Okay, and then we have to do basically the way I'm thinking about it, right? Is we have a k low, we have a k high, and we're gonna say, okay, if we do the minimum, the middle. It's the max at piles. So 10 hours to eat all the bananas. If it was 1, the minimum rate is 2. Okay, I don't want to go like in one order because then I need to go 25 iterations. It's gonna take way too long. Like, it's not efficient. So I need to do like some middle stuff. So I'll go. Okay. So I liked what we did before. So, but I'm like actually understand what I'm writing. So while k low is less than k high. Right, we need to do the code, right? Then we need the like increase / decrease. So for the actual code, we're gonna say counter equals 0, k mid equals k low plus k low plus k high divided by 2. And then we're gonna do it with k mid. So we're gonna do for I in range 0 till then piles. Oh, I don't want to like edit piles though, because piles is gonna be there forever. I'll just do like temp equals piles at I, while temp is bigger than 0, is bigger or than 0, temp minus k mid counter plus equals 1. Alright, so at the end of this for loop, we're gonna open VS Code because I would like to attempt to test this to make sure. So wait a minute. And then, I don't want to like change. I just want to break, and then I want to print counter. Is this gonna be infinite loop? Okay, it exited. It's just not like this is like. Print. Oh. Six. Because 1 plus 4 double divided by 2 is that. Okay. Print counter. Print k mid. Okay. So what we're gonna do is now I need to create the rest. So I'm gonna say, okay, if k mid is less than target, is less than h. If k mid is less than h, I want to take k low and plus equals 1. And if k high, oh, wait a minute, no. If counter is less than that, and if counter is bigger than h, I want to take k high and minus equals 1. And then I want to check if it's the lowest. And then we'll do a little if statement saying here, if counter equals h, return k mid, or we'll print the answer is, just for now. And then if not, we do like this lower higher thing, and we want to see, okay, what's the lowest one? So if I do this and I run this, 5.3. So it stops at 5.3. Well, that's not the answer though. Ooh. How about, what if we do this? if k low is less than h, oh, I might be cooking. If k low is less than h, we're gonna do temp. Oh, I already have a temp. Shit. Just say r equals boom r dot append k mid, because it's under, and then after we print out r min r. Print answer is okay. This actually might work. I think this will work. So we'll copy back everything. So we'll like clean everything up. If wait, if it's equal to h, yeah. Wait, do I want to return the minimum one? No, I don't want to return the minimum one. I want to return the maximum one. Return k mid, r dot append k mid, and then at the end we're gonna go return max at k mid. If I do this and I run it, am I gonna get answers 3? No. But it should be only if it shouldn't append it if it's lower. Like if it's 3, right? If k is 3, k mid's 3. How much we get? We get 1, 2, 3, 4, 5. Right? Our counter becomes 5. We want the highest counter. And the highest counter is going to be the lowest one. We'll try minimum. If I run this, int object is, oh. Array equals that, array dot append k mid. Okay, this one worked, this one did not work. This one said, oh, okay. So in this one, expected output is 25. Oh. Yes, I choked up because we never actually tried 25. I just changed the mid. Okay, we need to reform the code. So basically, we need to reform the code. This k mid stuff does not actually work. So what we're gonna do instead is I'm gonna do it with k low and k high, and then we'll replace k low and k high. So k low, k high, an array right there. I'm gonna do it like we'll comment this out for now. But basically, so counter equals this. I need to do it for k low, and then do it for k high, and then whatever k mid is, I need to replace that one. So yeah, okay, so I'm gonna go here and I'm gonna go, so for ein range 0, len piles, and for ein, so we'll keep doing this. K low here, k high here. So now we have, oh, I need to check. I need to keep this counter. Okay, so now I have a low counter and a high counter. I have a low counter and a high counter, and I need to now I need to go while. Now I need to do a while statement and do while K low is K high. Yeah, I think K low K high would work. K low is less than K high. K mid equals K high Nah, I think I'm just cooked. I think like I have no idea what I'm doing. I think we have to. I think we're just gonna look at the solution, try to understand this. Okay, so LR. So we like. Ooh. Res equals that one. Okay. That's what we're starting with. So while L is less than or equals to R, K is L plus R divided by 2. Okay. Total time equals 0. For P in miles, total time plus equals math.ceil float P dot K. If total time, so like basically this one line of code right here, these two lines of code right here is this. Except his is just more. And then if total time is less than or H, we set a res to equal this. And we do R equals K minus 1, else L equals K plus 1. And then we return res. So no matter what, res by default is going to be the big one. And then every time we find something smaller, we set to that. Oh. That makes so much sense. We set res equal to the max, right? In the case that it's like this, because 25 will hit everything. And then while L is less than R, if when we do the whole calculation and every time we find a total time that's less than H, we set that equal to K. And then R equals K minus 1. That'll decrease it, and this will increase it. So it makes sense. It makes sense. Oh. Yeah, just for fun though, I'm gonna run this up just cause for fun. This should work, right? I just want to see if like this was correct. No. Oh, I have minus K high, but it should be minus K. Yeah, there you go. Should work. Nope. Total time. Word is not associated with a value. Total time is associated with. No, it's not. Okay, so it did work. So at least this was correct. Like I'm happy this was correct, but yeah, I definitely could have thought of that. Thinking I have to understand this bisection, or this binary search, because I keep trying to do like bisection search, I guess. But basically, we have a left, we have a right, and we have a middle. We have a left, we have a right, and then we have a middle. We find out what the thing is for the middle. By default, it's the highest one. And every time it gets lower, we keep making it lower, smaller, and smaller. L equals k plus 1, or R equals k minus 1, after we divide it by 2. Let's figure out why this is the case. Why do you just minus equals 1? R equals k minus 1, right? So for example, right, we have 1 and 4. No, we'll do 1 and 6. So 1 and 6, 7 divided by 2 is 3. And then 3 minus 1 is 2. Now we say it's between 1 and 2. And then, or here, if it's not right, we make it 8. L equals k plus 1, so whatever so it's, it makes sense now. So it's like, whatever we're doing, right, if we have two ends, right, saying we know that it's less, right, we just say, okay, now we're going to search between here and here, and this becomes a search. Okay, so that makes sense. You're joking. Tell me I need to use this. Like if I don't use that, it doesn't work. But it's the same thing. Alright, well, we'll get back to that. At least you learned something. So that was the two Koko either bananas in search of 2D matrix. I guess I'll see you guys tomorrow.